Welcome to INFOPedia. Today we're exploring one of the most fundamental particles in the universe, the electron. You might think of electrons as tiny balls orbiting the nucleus of an atom, but that's just the beginning. In reality, electrons are much more complex and fascinating. An electron is a subatomic particle that carries a negative electric charge. It's incredibly small, with a mass that's only about 1 by 1,836th that of a proton. Despite their tiny size, electrons play a crucial role in determining the properties of atoms and molecules. In fact, without electrons, chemistry as we know it wouldn't exist. Did you know that in a hydrogen atom, the electron whizzes around the nucleus at over 2,000 kilometers per second? That's incredibly fast. Let's travel back to 1897, when J.J. Thomson made a groundbreaking discovery. While experimenting with cathode rays, streams of particles emitted from a cathode in a vacuum tube, Thomson found that these rays were composed of negatively charged particles. He called them corpuscles, but we now know them as electrons. Thomson's experiments showed that these particles had a very high charge-to-mass ratio, suggesting they were much lighter than atoms. Later, in 1909, Robert Millikan determined the precise charge of the electron through his famous oil drop experiment. These discoveries laid the foundation for our understanding of atomic structure. Electrons are not just particles, they also behave like waves. This is known as wave-particle duality, a cornerstone of quantum mechanics. Because of this, we can't say exactly where an electron is at any given moment. Instead, we use probability distributions to describe where it's likely to be found. These distributions are called orbitals, and they come in different shapes. S orbitals are spherical, p-high orbitals are dumbbell-shaped, and so on. Additionally, electrons have a property called spin, which is a form of intrinsic angular momentum. This spin is crucial for understanding how electrons pair up in orbitals. In an atom, electrons are organized into energy levels or shells. Each shell can hold a specific number of electrons. The first shell can hold up to 2 electrons, the second up to 8, and so on. The way electrons fill these shells follows certain rules, leading to the electron configuration of an element. For example, carbon has 6 electrons, arranged as 1s power of 2, 2s power of 2, 2p on power 2. This configuration determines the chemical behavior of the element, such as how it bonds with other atoms. Electrons are essential for chemical bonding. When atoms come together to form molecules, it's the electrons that interact, either by sharing or transferring between atoms, creating covalent and ionic bonds. Beyond chemistry, electrons are responsible for electricity. The flow of electrons through a conductor powers our devices and lights up our homes. Moreover, electrons are behind the colors we see in everyday life. When electrons jump between energy levels in atoms, they emit or absorb light of specific wavelengths, producing the vibrant colors in fireworks, neon signs, and even the beautiful auroras in the sky. One of the key experiments that highlighted the particle nature of light was the photoelectric effect. In this phenomenon, light shining on a metal surface can cause electrons to be emitted from that surface. This couldn't be explained by classical physics, which treated light as a wave. It was Albert Einstein who proposed that light consists of particles called photons, each carrying a specific amount of energy. When a photon hits an electron, it can transfer its energy, ejecting the electron from the metal. This explanation earned Einstein the Nobel Prize in Physics in 1921 and further solidified the quantum nature of electrons and light. In our modern world, electrons are indispensable. They are the workhorses of electronics, enabling the functionality of everything from smartphones to supercomputers. By controlling the flow of electrons through semiconductors and transistors, we can process information at incredible speeds. So next time you use your phone or laptop, remember that it's all thanks to the humble electron. That's all for today's video on electrons. I hope you found it enlightening and that it sparked your curiosity to learn more about the subatomic world. If you enjoyed this content, please like the video, share it with your friends, and subscribe to INFOPedia for more deep yet accessible learning experiences. Until next time, keep exploring.